Alright, so example 5 looks at a thinking question. So this one's going to be a little bit of an extension of some of the concepts you know in the exponential functions unit. And so this question says, in favorable breeding conditions, the population of a swarm of desert locusts can multiply tenfold in 20 days. So just the first sentence of the question has some information that we haven't seen before. And so just to clarify one of the concepts that are here, it says that it can multiply tenfold in 20 days. So multiplying tenfold is similar to multiplying twice the amount, or having triple the amount, or quadruple the amount. So double means you're multiplying by 2, triple means you're multiplying by 3, quadruple means you're multiplying by 4. Tenfold just means that you're multiplying by 10, okay? So all that really means is you're looking at an increase of the number of locusts. So I know that we're going to have a growth ratio. And all this means is that your growth ratio value is going to be 10. That's what it's going to be multiplying by each time. Okay, you're also told how long it takes for it to actually increase by a factor of 10, or by a ratio of 10. And so we know that it takes 20 days for that to happen. And then it says, how long will it take for the population to increase to 1,000 times its original population? And then explain how you solve this problem. So I'm noticing in this question that we're not actually given the initial population, so we are going to have to make some assumptions. And we're trying to figure out when it'll increase to 1,000 times its original population. So to start, I'm going to explain as I go through the question. So first of all, what I'm going to do is create an equation that models the population of the desert locusts. And I wrote desert locusts. I don't think they're very yummy. So of the desert locusts. Okay, and so we're going to use P of t to represent the population. And we don't know what the initial population is, so we're going to leave that as P naught. So let's start by writing P of t equals P naught times, and instead of having doubling time, we're going to use a growth ratio of 10, because that's what you're going to be multiplying by each time. And if I just put a t in the numerator, then that means every day the population is increasing by a factor of 10. Now, that's a lot, but we're told that it's increasing by a factor of 10 every 20 days. So I need to put the 20 in the denominator of the exponent. Okay? And now we're trying to figure out how long it'll take for the desert locust population to increase to 1,000 times its original population. So we can assume that the population we're looking for is equal to 1,000 times the initial population. So I'm not going to choose a number, because then I'm only specifying it for that particular case. But I'm going to assume that because I'm looking at 1,000 times the initial population, I actually don't need to know what the population value is. I'm just going to multiply the initial population by 1,000. So I can substitute in 1,000 P naught for P of t on the right hand side here. So I get 1,000 P naught equals P naught times 10 to the exponent t over 20. And now at this point we can solve for t. And we're going to look at how we can solve for t in a second as well. So the first thing I can do is try to get the exponential part by itself, just like I've always been doing. And I can do that by getting rid of the P naught that's at the front. So I'm going to divide both sides by P naught. And you'll notice that something very convenient happens. The P naught on the left side and the right side cancel each other out. And I get 1,000 equals 10 to the exponent t over 20. And now to solve this, what I need to do is write the left side and the right side both with the same base. So I need to rewrite the left side, or rewrite 1,000, as a power with a base of 10 in order to compare exponents. Okay, so I'm going to get 10 to the exponent 3. That one was an easy one to do. I didn't have to play around with it too much. Okay, and then because the bases are the same, then I know that 3 has to be equal to t over 20. And so if I solve for t at this point, I get 60 is equal to t. And so that's how many days it would take for the population to increase to 1,000 times its original population. So this is almost a level 3 solution. You can make this a level 4 solution by justifying your work. And how would you justify your work? Well, you can substitute in the time value into the original equation and show that at t equal to 60, it's 1,000 times the population. Okay, so that's a quick little thinking question for you guys to look at. Okay, just quick practice questions.